No problem. I just need to make up a sign. Multiplying both twice by -1 is not going to make any difference. It's 1. But this piece will become what? And this piece will become what? What is that top?
dy.
Very good. What is the denominator replaced by?
Y squared.
That's it. Awesome. Do not copy anything yet. Do not copy anything yet. Wait. So we have dy over y squared. These are the limits of integration for t. I cannot copy them here. They're not the limits of integration for y. So when t is 0, how much is y?
1.
That's it. When t is pi over 6, how much is y?
Square root of 3 over 2.
Excellent. So that's the biggest difference between indefinite and definite. The limits of integration cannot be copied for the variable t to the variable y. They cannot be the same. Most of the time, 99%. So you have to be careful once you use the substitution. We do not go back. If it's a definite integral, please don't go back. It will be a waste of time. The answer is a number. You don't want to go back to the previous variable. There is no need. Because the answer will not depend on t or y or z. It will just be the same number no matter what. Okay, so then, now, we have to identify what function prime is y squared, 1 over y squared. So it will be negative y to negative 2 plus 1 over negative 2 plus 1 from 1 to the square root of 3 over 2. This is -1, which will take care of this. So this is basically 1 over y. From 1 to the square root of 3 over 2. We plug in the square root of 3 over 2 and flip it. 2 over the square root of 3 minus 1. You can write it as 2 minus the square root of 3 over 3, or the square root of 3, or rationalize. It's up to you. So this is good, or just rationalize. And you have 2 the square root of 3 minus 3 over 3. So the difference between, one difference between the indefinite integral, first of all, we get a family of functions. Here we always get a constant, a number, and we do not go back to the previous variable. We are using y, we stay with y till the end, we choose the correct limits of integration, and at the end we get the same number. Even if you want to go back, I don't recommend it. If you solve in terms of t, you'll get the same number, but why not solve in terms of y, which is the easiest of the two? Good. Anything else? Choose anything else.
Professor, I have a question.
Yes, please.
So on the one we just did, so we don't need to do plus c because it has endpoints, or?
Right. So the fundamental theorem of calculus, the integral says this, is the antiderivative evaluated from a to b, which is f of b minus f of a. You could say what happens to the constant. Let me show what happens to the constant. So if you want to write it as f of x plus a constant c from a to b, then you will have f of b plus a constant minus, in parentheses, f of a plus the same constant. And when you distribute, the two constants go away. And you still get this.
Okay, that makes sense.
Right? So this will always be a number as the final answer. Good. So let's share again. Please choose anything else. you would like to work on? Yeah, I'd like to look at 67. So I'm on page 6. So the integral from negative pi over 4 to pi over 4 from x to the third plus x to the fourth tangent x dx. Okay. I forgot to mention here, every time we calculate, I did say it but not on this one, every time we calculate a definite integral, what do we have to check first?
It's continuous on
Excellent. The function is continuous between 0 and pi over 6 because cosine is not 0 between 0 and pi over 6. So this will be continuous. Okay. Now, this is continuous between negative pi over 4 and pi over 4. It's not defined at pi over 2 and negative pi over 2, but that's not the issue. So this is continuous. Now, what else do you notice here? When we look at this integral, what do we notice? We notice a symmetric interval. Negative pi over 4, pi over 4. Every time we notice a symmetric interval, after we check continuity and the symmetric interval, what do we need to think of? Always. Whether the function is odd or even. What if it's odd? What will the answer be?
Would be 0,
Excellent. What if it's even?
twice as much.
Exactly. You mean twice from 0 to pi over 4, blah, 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 dx. Correct. So please remember, continuity, I notice symmetric interval, then I check whether the function is odd or even. So let's go back and check. Is it odd or even? Or none of the above? A function doesn't have to be odd or even. How do we check if it's odd or even? What do we need to calculate or determine? So in other case, we have to find f of negative x. So f of x is x cubed plus x to the fourth tangent x. So now if I want to determine f of negative x, then I have negative x to the third plus negative x to the fourth and tangent negative x. Now, from the trig functions, which functions are odd and which functions are even? Anyone remembers which functions are odd, which functions are even from the trig functions? Only cosine and secant. Only cosine is even, and the other function that has only cosine in it. Everything else is odd. Sine, tangent, cotangent, cosecant, I meant to write. Okay, only cosine and secant are even. So tangent is odd. So tangent negative x will change into negative tangent x.
So real fast, those are the odd ones, the ones that don't go through the origin, right?
The odd ones are the ones that are symmetric with respect to the origin. The even ones are symmetric with respect to the y-axis.
Okay, yeah, that's what I was picturing in my head, thanks.
Okay. So, continuing this, f of negative x is negative x to the third. This is negative x to the fourth tangent x, which is definitely the opposite of f of x. So is this function odd or even?
It's odd.
It's odd. So we come back and we say, lucky us, odd function on a symmetric interval. The answer must be 0. Odd function on a symmetric interval. And there is nothing I need to do here. If I change this into anything else, we will not be able to solve that integral.
Is that integral even solvable easily, or is it like these types of problems just meant to be solved like this?
Not necessarily. You'll see what happens in Calc 2. There are other techniques of integration.
Okay.
Yeah. Very good. Moving on.
But if we were trying to solve it with the rules that we have now, would we still be able to get 0?
Oh yes. That integral will always be 0 for the symmetric on the symmetric interval. With the symmetric interval and an odd function, no matter what technique you use. So it's like saying if I solve a quadratic function, a quadratic equation by factoring or by quadratic formula, will I get the same answer? Of course. Yeah. However, there is a lot of merit to that question. I may have the integral from f of x dx, and I may get two different answers. It is possible to get an f1 and an f2. Both these differentiated will give us f of x. So it is possible that I get an answer and you get a different answer. Both are acceptable. Of course, plus a constant c. Oh, I'm sorry. I was showing here. So it is possible that the integral from f of x dx, you come up with this, I come up with this, but both are correct. And they're not identical. So it is possible. So don't get discouraged. Okay, anything else? I think we should look at least one more with definite. Let's use some natural log or e. So let's choose from among 75, 76, 77. Please choose. 76. So in 76, let me copy it. So the integral from 0 to 2, x minus 1, e to x minus 1 squared dx. Perfect. Okay. So any substitution that you can think of?
X minus 1.
Squared. I want this to disappear. I want a clean, nice e to y. That's my target. I don't like a function inside e to x, right? I don't like something like this complicated. I just like plain e to y. So let's see if I can, right? I need dy. Can anyone give us the dy?
2 times x minus 1 dx.
Excellent. Do I have it? Of course I do. I don't have the 2. Who cares? I can make up any constant I want. As long as it's a factor, I can make it up anytime. I multiplied by 2 and divided by 2. That's 1. Didn't make any change. So from here, can anyone dictate? Do not copy the limits of integration. Let's deal with the inside. Replace inside, and then we'll deal with the limits of integration. Anyone?
Is it e to y dy?
That's it. Isn't that much nicer than what we had? Okay, so now let's plug in 0 to find the lower limit for y. What is the lower limit for y?
Is it 1?
Very good. 0 minus 1 is negative 1. Negative 1 squared is 1. Perfect. Now let's plug in 2.
Also 1?
Uh-huh. So what is the answer? I don't have to calculate anything.
0.
0. Good. Let's share again. See if we need another. Anything else?
Should we do 80?
You said 80? 80?
Yes.
Very good. Yes. So 80 it is. So we have the integral from 1 over to 16, x to 1/2, 1 plus x to 3/4 dx. Perfect pick. Let's do it. Good. So let's think of a substitution. As long as we can make up the dy minus a constant. The constant is no problem, no brainer.